Assalamualaikum warahmatullahi wabarakatuh. My name is Ildina Nurna Dira binti Roshamsani. My matrix number is 88201081. So today I will present about closed loop system for number 2. This is number 1. This is with the mathematically calculation using characteristic equation that I have calculated. And we get the poles is -1 and -1. And for the 0 stated here is empty matrix, means that no 0. So this is sketch that I have did. For the poles is -1, so this be the on the half plane, and it's repeated. After we do the mathematical calculation, we have to use MATLAB to confirm it, and we have to conclude it and decide whether it's stable or not. The design will be like this. This is the step: subtract transfer function and scope. Transfer function is I set it here numerator for 0, 0, 20, and denominator is 1, 2, and 9. Everything is set here. So here I use decoding. I insert the coefficient of the equation, and then we use BZMap to get the pole 0 plot. And then instead here is -1 and -1, same as what I calculated in mathematical calculation. And the pole 0 is empty matrix. And this is what we get. So damping is 0.333, which is underdamped. So from the pole 0 map, we can conclude it is the system is stable. In this pole 0 map, the poles is on the left half side, which is shown that the system is stable. And if single pole on the right half side, it is unstable, and if it is marginally stable, lie on the imaginary axis. We move to objective 2. For the objective 2, this is the Simulink model, and we have to set up the HS output step. Here is the info from the step response. The rise time is 0.4568, which will be right here. Settling time is at 3.7005, right here. So it's right here, and overshoot is 32.93%, and for the amplitude, which is 2.95, and the peak time is 1.11. For this system, we can say it is stable, reach its steady state at 6.209 seconds. And the actual value of a system output is for steady state is 2.22. Underdamped, there is oscillations. It takes longer period of time to reach a steady state, which is 6.209 seconds. For the objective 3, I use PID controller, which is the more common controller we use, and it is the info we are going to see is a stable system. After recording, we going to get the feedback for the system PID, because we use PID controller, so we stated here is system PID. The info from step response, it's shown here rise time at 0.3365. The peak is 1.01, at the time 0.5739. To meet the design requirement, I use PID controller, and stated here is overshoot is 1.2812, which is met the design requirement. It is less than or equal to 10%, and for the settling time is less than or equal to 5 seconds, and we get here is 2.653 seconds. Is a steady state error is less than or equal to 2%, and I got it here is 0.000. How to calculate the steady state error is first is the desired value, which is 1 right here, desired value, and minus actual value of system output, which is 0.998 is right here, and we get the steady state error, which is 0.002. That's all from me. I will pass the presentation to my next member. Thank you.